Hello, hi everyone. This is Teacher Alpha. Okay, welcome to another yet second session for the Math Clinic. So we are still looking at the series of coordinate geometry. We're learning how to find the gradient. In the first video, we learned how to find the gradient when you're given two pairs of coordinates, and we also learned how to find the gradient when you're given a straight line equation. Okay. Let us learn how to find the gradient of parallel lines and perpendicular lines. Now, before I even go any further, please note that the equation of all straight lines, the y-intercept form of all straight lines looks like this. This is a linear function in which m is the gradient. All right. Then please bear in mind that parallel lines share the same gradient. So the gradient of the first line is equivalent to the second line. Then with perpendicular lines, their gradients are opposite, meaning when you multiply the first gradient by the second gradient, we always get a product of -1. So please, when you're finding the gradient of a parallel and a perpendicular line, you have to bear in mind of these two factors. All right, let's delve right in. Okay, given that y is equals to -3x plus 20. So we have been given the first equation, okay? Y is equals to -3x plus 20. And I've been given the second equation, y is equals to jx plus 5. Okay, find the value of j. Now, when you look at this question, it says the equations are parallel. It means they share the same gradient. So equation 1, what is our gradient? Our gradient is -3. Are we together? And if our gradient in the first equation is -3, then it means that in the second equation our gradient is -3 as well. So therefore, the value of j in this situation is negative what? -3. Why are we predicting it to be so? It's because using this formula, the y-intercept form, the number next to the variable x is the gradient. So we have found the gradient for question number 1. So these two equations are parallel. These straight lines are parallel with each other. Okay. Okay. So we have learned how to find the gradient of parallel lines. Let us also learn how to find the gradient of perpendicular lines. Given that y is equals to -3x plus 20 and y is equals to mx plus 5. Okay, they are perpendicular. Now, what if our straight lines are perpendicular? What if our straight lines are perpendicular? How do we find the other gradient? This is where this formula comes into play. So let's identify the first gradient. In this case, our gradient is -3. How do we find our second gradient? Well, we're going to say m1 times m2 equals -1. What is our first gradient? -3. So to find m2, we're going to make m2 the subject. So I'm dividing both sides by -3. You cancel, you cancel. So m2 is equals to, you cancel out the negative. So our gradient for this other straight line is 1 over 3. So we are able to see that the gradient of perpendicular lines are inverses or opposites. Inverses or opposites or reciprocals, if you like, if you will. But I don't like to be too technical. All right. So we have learned how to find the gradient of perpendicular lines and parallel lines. Now, lastly, last but not least, so we've learned how to find the gradient of perpendicular lines. Last but not least, as I earlier mentioned, Now, given that the gradient of a straight line passing through the points 1, comma 3, 3, comma y is 2. So we are told that the gradient, okay, so we are told that the gradient of these two pairs of coordinates is 2. Now, I told you in the first video, I said when you are given coordinates x, comma y, the formula used to find the gradient in a situation like this is m is equals to y2 minus y1 over x2 minus x1. Without further ado, so let's identify the respective values. Okay, so for sure our gradient is 2. The question says given that the gradient of a straight line passing through 1, comma 3 and 3, comma y is 2. So our gradient is 2. That's what our examiner is telling us. And that is our x1, that is our y1, that is our x2, that is our y2. So we're going to substitute now. So we're saying m is 2, our y2 is y, what we are looking for, our y1 is 3. Don't forget, you obey the formula. So y2 minus y1 first. Then x2, we're saying 3 minus 1. Okay, at this point, we are going to work it out. 3 minus 1, we're getting a value of 2. You introduce a 1 there, then you're going to cross multiply. Now, I will start multiplying the minor diagonal. Why? My subject y is on the right. So 1 times y minus 3 is y minus 3. 2 times 2, the answer is 4. When negative 3 crosses the equal sign, it changes to positive 3. Therefore, the value of y is 7. So this is telling you that it's not all the time when you're asked to find gradient. Rather, they can ask you to find y2, y1, or x2 or x1. Thank you very much. See you in the next session.